Hi everyone, I just woke up in Barcelona. I'm excited to be here and to go interview Professor Simó Schwartz, who directs a nanomedicine center here in Barcelona, and he's also the deputy director for translational research at Vall-d'Hebron Hospital here. And in addition to that, he is the president of the European Society for Nanomedicine.
Welcome to Barcelona.
So tell us, what are your main research goals in nanomedicine?
The main ones are based on providing new treatments for diseases, especially in cancer, which is our main molecular background. It's based on cancer. But the second one is also rare diseases. We think that nanomedicine has a very clear future impact on those diseases. We are trying to develop different carriers, different drug delivery systems, and that's because the use of systems that might make feasible the enzyme replacement therapies that could be very useful. And in that sense, one of the systems that we're using is the use of extracellular vesicles.
So what are the main struggles in your research and how did you overcome them?
Well, to me, there are two main hurdles that we have to face at all the times. One is the funding. That's something that in nanomedicine has a very strong impact. It always has an impact, but in nanomedicine, especially important. The main reason is that most developments that we are doing and people is doing in nanomedicine, so developing a new drug, it is extremely expensive. So therefore funding is always a problem, a hurdle to find out how to do things. But the other thing is how to face the need of developing this nanomedicine and the point of view of what kind of disciplines you have to get involved in that. So and that's another hurdle. I mean, it is very difficult to just be able to do everything in one single place, one single lab. So certainly anything that you have to do, it requires a very, very good basic science behind, then a very deep knowledge of what you have to do and why, and then how to do this and to do it in a way that it makes sense and it can actually reach preclinical trials and the clinical practice. So it means that you need a lot of different disciplines to get involved, and this means many different laboratories, many different experts, and to work together. And that's a hurdle that it can be solved, but it's something that it's sometimes a fish eating the tail. So you need a lot of funding, a lot of people, and a lot of people need a lot of funding. So and a lot of time to do things. This is another difficulty that has.
How do we increase clinical translation of nanomedicine?
So to me there are two things which are crucial. The first one is to have a very good basic science behind, as I was saying. So that's fundamental, because if we don't really have enough knowledge on the basis of what we have to know in terms of providing something that will have a chance to work, it's going to be impossible. So sometimes that basic science behind fails. So there are many questions which are small ones, but very crucial and important ones which we don't care to answer, and that's something that we should avoid. The second one is to make sure that what we do has a clinical translation per se. So it means that it's going to be important for the clinician. So we need to know very deeply which are the main unmet clinical needs, so we can provide a solution which fits on what it's going to be needed, and it had a chance to be implemented as such on the clinical practice.
Always putting a lot of attention in being sure that we are actually providing something that answers a very clear unmet clinical need for the clinical practice. Otherwise, it doesn't make sense to do anything.
So what is your advice for early career researchers in nanomedicine?
So I think the best advice that I can actually give them is to try to go beyond the knowledge, to increase the knowledge that they have in different disciplines.
So where do you see nanomedicine going in the next 5 to 10 years?
Well, I think that we will be seeing a lot of different nanoconjugates and delivery systems going into clinical trials. We'll see how many of them succeed into reaching clinical practice. That's another question. Perhaps the basic science which is behind what most of these developments is not as good as it should. So probably there will be failures of, I think that there will be failures of many of the systems that are being tested. But hopefully some of them will succeed. So my expectation is that nanomedicine will provide new treatment and it will be successful. Some of them are already in clinical trials and some of them can reach already the clinical practice. So we should be optimistic.
Fantastic. Well, thank you so much.
Welcome.